Hello students, in lesson number 8, we are doing the exercise numericals. So let us move further. We are reaching to question number 6. See the question. Figure shows the distance versus time graph of 3 objects A, B and C. Study the graph and answer the questions. Okay, so we know how to interpret the graph. So by studying this graph, we are trying to answer the following questions. So this is the graph. It is distance versus time graph. On y-axis it is distance, on x-axis it is time. Distance is in kilometer and time is in hour. Now, these 3 straight lines shows the distance, shows the motion of 3 objects A, B and C. Okay, one is for B, C and another is for A. Okay, so when the observation starts at 0 point, the B object starts. The distance changes with time, so it's traveling same as for A and C. So see the following questions. Which of the 3 is traveling the fastest? Okay, out of these 3 objects A, B and C, which is the fastest? It means fastest means the object traveling with more speed, right? So which object is having the highest speed? We know that speed can be found from the graph distance versus time graph. How can we find the speed? By taking any 2 points on the graph A and B and take a C point such that it makes ABC triangle. If you remember this, okay? So by taking the ABC triangle, take BC, the ratio of BC upon AC will give the speed of that object, right? So for any of the 3 graphs, here we are not going to find the speed, but remember here, the ABC triangle and the ratio of BC to AC is for the slope of the graph. Okay, so the object all are standing line, so all have slope, right? But the object with the which is having the highest slope will be having the highest speed. So which line has the highest slope? Highest slope means the object having a steep slope. Okay. See, as you can see, for A, the slope is less. For C, it is quite more, and the line for B is making more angle with the horizon. Okay. So more angle, it means a very steep slope, right, and very high slope for the line. So all the slanting line has some slope, and more the angle with the horizon, more the slope. Okay, so we can say that object B is very steep line, making more angle with the horizon. So that's why object B will be traveling the fastest. Okay. Now second question, are all 3 ever at the same point on the road? A, B and C object ever meet at any point? So if we see, if the line intersect at each other, then that will be the meeting point. So A, B and C, these 3 lines ever meet at any point? At this point, the graph of C and graph of B will meet. So B and C meet here. At this point, A and B will meet. At this point, A and C will meet. But at any other point, there is no point where all the 3 lines meets. Okay, it means that these 3 objects never meet on the road. Okay, so no, all objects are not meeting at any point on the road. Now third question, how far has C traveled when the B passes A? This is important question. How far has C traveled when B passes A? It means when B and A meets C. B and A meets at this point. This point. Where B of the object A and B meets. Right? If at this, let me say this at this time. Okay, how can we find the time? On time axis. And we need to find the distance traveled by C. Where? At which time? At this time. So where is the graph of C? This one. At this time, the C, how much distance it has traveled? As you can see in the graph, this on the same time the C has traveled this much distance, which shows 8. That means 8 kilometers. But remember here, object C has not traveled from 0 point. Okay, it has not traveled. It has not started with 0 position, 0 kilometer. The C at initial time C has already at some distance from the reference point. So we need to find from initial point to this A, how much distance traveled by C at this, right? On this time C is reaching to here, but it has traveled from here. So we need to find this much distance. So it is not the A. If it has traveled from 0 position, then at this time C has traveled 8 kilometers, but it has not traveled 8 kilometers. It has traveled this much distance. How do we find this distance? By counting the squares. How much square box it has traveled? So by counting square box, we can find the distance traveled. But we don't know how much one square box. One square box is equal to how much kilometer? We don't know, right? It is not like that one square box is equal to 1 kilometer. So count the square box and it multiply with 1. It's not like that. Here the scale is different. Okay. Here it is given. If you count this, 7 boxes are there. 7 square box equals to 4 kilometer. We need to find the value of 1 square box. Okay. So how do we find it? From the graph, 7 square boxes equals to 4 kilometer. It is given, right? So 1 square box equals to how much kilometer? Right? If we know the value of 1 square box, then according to the number of square box traveled by the object, we can find the total distance traveled by it. Understand very carefully. So we are finding 1 square box. So value of 1 square box. 7 square box equals to 4 kilometer. 1 square box equals to how much? By cross product. 1 into 4 divided by 7. Right? Equals to 4 upon 7 kilometer. Okay. It means 1 square box has the value 4 by 7 kilometer. So the distance traveled by the car C when B passes A at this time, when B passes on this time, C is reaching to here, and from initial point to 8, how much square box? Can you count that square box? Okay, count from initial to this time. It has, if you count it, it is actually 10 square boxes. Okay. So we can calculate the distance. 1 square box equals to 4 by 7 kilometer. Then 10 square box equals to how much kilometer? Do the cross product. 10 into 4 by 7 divided by 1. So 10 4s are 40 upon 7. If you calculate it, it will give 5.71 kilometer. It means from initial point to this time, the C object has traveled 5.7 kilometer distance. Okay, got it? Next. How far has B traveled by the time it passes C? Okay, B passes C. At which time B passes C? Here. B and C graph meets here. So how much distance traveled by B? Okay, B starts from 0. Okay, so count the number from here. From here to when it meets C, at this time, how much distance it has traveled? So distance we can obtain from y-axis. Okay, so extend here, how much square box it reaches. If you calculate the distance traveled by B by the time it passes C, if you count the square box, it is 9 square boxes. So we can find the value of 9 square box. 1 square box equals to 4 by 7 kilometer, as we have already calculated. So 9 square box equals to how much? Take a square cross product 9 into 4 by 7. 9 4s are 36 by 7 equals to 5.14 kilometers. Okay, so we can calculate. So this is how the graph-based question answers can be done. Further, question number 7. See the question: a ball is gently dropped from a height of 20 meters. If its velocity increases uniformly at the rate of 10 meters per second square, with what velocity will it strike the ground and after what time will it strike the ground? Okay, so we need to find a ball is gently dropped from 20 meters. So that ball will fall down. On downward motion, its velocity increases at the rate of 10 meters per second square. Okay, and after some time it reaches to ground. Okay, so at that point the velocity will be maximum. Okay, because on downward motion the velocity increases. So at the last moment before, okay, when it touches the ground, after touching it will stop. Okay, but the moment it touches the ground, at that time the velocity of the object will be the highest. So that point, that velocity we need to find, and after what time will it reaches to ground. So wherever there is a uniform accelerated motion, okay, when the velocity changes, at that time we can use the three of the equations, which are the equations of motion for uniformly accelerated objects. So that three equation we can use. So what is the data given? Data given that the object at some height, it is dropped and it dropped from 20 meter. Okay, so and when it reaches to ground, so basically it will travel 20 meter distance to reach the ground. So this height is nothing but the distance traveled. So S is given 20 meter. At the rate of change of velocity, that is called the acceleration. So acceleration A is given 10 meter per second square. We are taking it positive because on downward motion velocity increases. So A will be plus 10 meter per second square. When any object, when it is just dropped from some height, it will initial velocity will be 0. Okay. So during this free falling, the initial velocity is 0 and then velocity increases. So U is taken 0. So we need to find the final velocity when it touches the ground at that time. So see the three questions, which equation we can use? V is equal to U plus AT. We need to find V. Okay. So for the first equation, we have U, yes. We have A, yes. But we don't have T. So we can't use this equation. In second, there is no V term. For the third equation, 2AS is equal to V square minus U square. We have A, yes. We have S, yes. We have U, yes. Okay, so all the quantities we have. So time is not given. So we don't use the equation with time term. We use the equation without time term. Okay, so third equation we can use to find V. So the equation is 2AS is equal to V square minus U square. We need V. Okay, so U square we take this side. So 2AS plus U square is equal to V square. Put the values now. 2A is 10, S 20 plus U is 0. So U square is 0 is equal to V square. 2 into 10 into 20 will give 400 is equal to V square. So V square is equal to 400. But we need V. So we take the square root on both the sides. So V square root is V and 400 square root is 20. So V is equal to 20. As it is a velocity, the unit will be meter per second. Okay, remember, don't forget to write units. V is equal to 20 meter per second. At that time, the object will be having the 20 meter per second velocity. Now, T, time we need to find. So for time we can use the two equations. Okay, we use the first equation because we now have V, we have U and we have A. So time we can find. V is equal to U plus 80. V is 20 as we have already calculated. U is 0, A is 10. Okay, so 20 equals to 0 plus, 20 is equal to 0 plus 10t. Okay, so that will be 10t. Now for t, 10 will come this side, as it is in multiplication on that side it will go to denominator. So 20 by 10 is equal to t. So 10 is 20, t is equal to 2 seconds. Okay, so after 2 seconds the object will reach the ground. Okay, that ball is reaching to ground. So this is how simply you can find the velocity or any of the term by using these three equations. Next, question number 8. See the question. The speed versus time graph for a car is shown in a figure. So observe it and answer the following. So figure shows the speed versus time graph. On y-axis it is given speed, that is in meter per second, and on x-axis it is time in second. Okay, and the nature of the graph is like this, a curve. Now the question is, find how far does the car travel in first 4 seconds. We need to find the distance, and if you remember how do we find distance? By taking the area under the graph. So in the first 4 seconds, that means from 0 to 4, during this time the car reaches to here. Okay, so the car travels this much distance. Okay, so if we find the area under the graph, we can find the distance. Shade the area of the graph that represents the distance traveled by the car during the period. Okay, so how can we, if we need to shade the distance, we can, during the first 4 seconds, okay, the velocity becomes here. Okay, it increases and the graph reaches here. So during this time, okay, the area under this graph up to 4 seconds only, the area under this much graph only, that gives the distance travels. Okay, so we can shade this area. Okay, so we need to find area of this region. That area will give the distance traveled by the object in 4 seconds. Okay, if it is in 6 seconds, we again need to find the area of this much. For 8 seconds, we need to find area of this much region. Okay. So first, the distance traveled by the car in 4 seconds, S is equal to area under the graph. And here it makes a curve, but approximately we are taking it as a triangle. Okay. So imagine this is a triangle, which will make a right angle triangle. So area for the triangle will be half into base into height. Half base, how much? 4, and height will be, as you can point here, it will give 6. So half into 4 into 6. If we cut it, 2 to the 4, 6 to the 12 meters. So during the first 4 seconds, the object has traveled 12 meter distance. Okay? Next question. What part of the graph represents the uniform motion of the car? Uniform motion means constant speed. So from the starting point, the speed is this shows the speed. Speed increases with time. But after here, the speed becomes constant. Okay? So parallel line with x-axis will give a uniform speed motion, uniform motion. So which region? The graph after 6 seconds. After what time? Here. After 6 seconds. It shows a straight line. So the graph after 6 seconds shows the uniform motion of car. Okay, got it? Next, an artificial satellite, that is the 10th one. An artificial satellite is moving in a circular orbit of radius 42,250 kilometers. Calculate its speed if its radius, if it takes 24 hours to revolve around the Earth. Okay, so this is a case of uniform circular motion where one satellite is revolving around the Earth. The radius of the circular path is given 42,250 kilometers, and the time 2 revolve around. It means to complete one round, the time is given 24 hours. So we need to find the speed for this circular motion. So which is also called the orbital speed. So orbital speed V is equal to, so the uniform circular motion we have speed formula 2 pi r upon t. Okay, we have r and t. So put the values 2 into 22 into 42,250 and divide by, okay, 2 pi we are putting 22 by 7, r is 42,250 upon t 24. Okay, so we can cut this, cut like this, 2 12s are 24, then we can again cut with 22, 6 2s are 22, 11 2s are 22, 6 2s are 12 and 11 2s are 22. Then 6 can be cut here, 3 2s are 6, 21,125, 2s are 42,250 and 3 2s are 6. Okay, so now we can't cut it. So multiply 21,125 with 11, divide by 7 3s are 25. That will give 11,065.48 as the distance, radius is in kilometer and time is in hour. The speed will be, speed formula will be, speed unit will be kilometer per hour. Okay, so this will give 11,065.48 kilometer per hour speed. That is the speed for satellite. So this was about the whole exercise. Question number 9, you can answer it, but numericals are we are doing here. So complete the exercise in your notebook, and still if you have any doubt you can ask me. Next lecture will start the next lesson.